To actually graph the histogram, we'll use the table to create two different graphs. One will be a frequency histogram, which is based off of the frequency that we've calculated. The other will be a relative frequency, which is based off relative frequency. The graphs will look exactly the same. The only thing that will change will be the y-axis, or the scale of the graph. To create a histogram, on the x-axis, we're going to put the class bounds or the midpoints. You can create this using class bounds or midpoints. Since we've calculated midpoints, we'll start there first. Your first midpoint is at 85, then 125, 165, 205, 245, 285, and 325. The y-axis will be our frequency. Our largest frequency from this graph is going to be 8. And now all we do is we draw the graph up to the scale of each frequency. So for the first class, we have a frequency of 6. The midpoints will sit in the center of each bar. This is why they are called midpoints. So we'll draw it up to 6, like this, like that. The next one has 8. The next class has 6. Notice that there are no gaps here because these intervals this is continuous data, and the intervals must connect to each other. The next one has 5, followed by 2, 1, and then 2. And here's the histogram, or the frequency histogram for this data. We're going to create the relative frequency histogram, which works the exact same way, except we're going to change the scale for this graph. This time, instead of using class midpoints, I'm going to use the class bounds, which is another way to do this graph. So again, using the class bounds, we'll start off with the lower bound, which is 65, then go up to the upper bound, which is 105. The next bound goes from 105 to 145, then from 145 to 185, 185 to 225, 225 to 265, 265 to 305, and 305 to 345. Instead of using frequency, we're going to use relative frequency, and we notice that our largest relative frequency is 0.267. So scaling this graph with nice numbers will look like this. Let's let our largest value be 0.30, 0.25, 0.2, 0.15, 0.10, 0.05, and 0. Our bars are going to cover the distance of each interval. So we'll start here at our lower bound, and our first class is up to 0.2 for the relative frequency, and we'll draw the bar to the upper bound. Next class is at 0.267, and you're going to draw your bars covering from lower bound to upper bound. 0.2 again. The next class is at 0.083, followed by the next class, which is at 0.67, then at 0.085, 0.033. And finally, last class is at 0.67 again. Notice both the shapes of these histograms are exactly the same. And the only difference is the scale that you're measuring on. We use a relative frequency histogram when we want to compare. So relative frequency is used to compare different distributions. And this is because, generally speaking, when you create a histogram for more than one distribution, the totals won't be the same. In order to compare and make accurate comparisons, we need to scale to the same thing. And because this is scaling to percents, it's easily able to be used to compare two different distributions.